Chapter 1, Database Systems. So, we're starting with the database systems. Let's consider some simple examples. Let's say your grocery store shopping, using banking services, video rental store, and your favorite clothing store. So, all of these use databases to keep track of customer, their inventory, their employee details, and their accounting information. So in here we can say databases allow for data to be stored quickly and easily and are used in many aspects of our day-to-day or our daily life. So let's see some of the examples here. As you see in the picture, there is a credit card picture here, then the Amazon services picture and your online course registration. So we every person we interact with the databases on a daily basis. So for example, how many of you have bought anything using a credit card during your past day, week, month, or year? So you can say here that none of those transactions would be possible without a database, correct? Okay, every person's details, all the details are stored somewhere in some point at a database. Or you may have shipped a document or a package via an overnight service or via a certified or registered mail, correct? You must have done that, and you must have checked your course catalogs and class schedules online while doing the online registration or signing up for the classes, correct? These are some of the examples of use of databases in our daily life. Okay, so next thing, why do we need databases? Okay, the first thing, let me tell you one example. Okay, so for example, let's say you want to purchase a car. Okay, so for that, you just go to directly to Google for a web search or Google search to look up a few insurance quotes or compare the car prices and the models. Okay, so incidentally, this is a good place to make the very important distinction between the data and information. I'll come to data and information later. So here in this way, we can say that our modern daily life is almost inconceivable without the ever present databases. Okay, and you can also see that how important it is that the database transactions are made successfully, accurately, and quickly. Okay, so these are some important discussion points in our database system, and after that we will, when we move to the database design part also, which is the heart of your whole course. So why databases? You have got a point about that. So in this picture, you can see some a lady when she wakes up for going to her work. Okay, before going to work, she searches for she looks up for her social accounts like social media accounts like Facebook or Twitter or Instagram. Okay, all of these use certain type of database where her details are being stored, her pictures, her messages, posts, or any sort of comments, so they're stored somewhere in a particular database. Now let's say during her lunch break she wants to pick up food or pick up the medicine from the pharmacy. So again, all the pharmacy details or all her data is stored somewhere in the pharmacy database, correct? Now let's say she wants to go to a grocery store. I have already mentioned this example, grocery store, or goes for shopping, any type of retail shopping. Suppose all those data are stored somewhere. Let's say she wants to make a flight reservation, airline tickets, same thing. And let's say she wants to make some online purchases, let's say from Amazon. So in Amazon also, as you know, every person who has one an account, their own details are being kept in a hidden place or in a secret place space, and which is not shared with other persons to maintain secrecy or privacy. Now, if we are going to dive into database systems, we must know about the key terms associated with it. Let's say data, information, facts, records, fields, all those things. So, what is a data? So, data are the raw facts from which the required information is derived, and data have little meaning unless they are grouped in a logical manner. And information, it usually is a processed form of our raw data, and in terms, finally, they are going to reveal a certain meaning to the user. If you see here, I have some data, let's say UT, let's say it's for Utah, or some random number, somebody's first name, another value, circle, SLC, and like this, some individual raw facts that doesn't carry a certain meaning. Okay, so data doesn't have any particular meaning, and to get a meaning from it, we need to convert it into an information which requires a context or a knowledge. Let's say we using all those facts, we are going to construct somebody's address. So this is somewhat looks familiar, right? Somebody's first name, then their city, apartment number, or the state name, and the zip code, and their phone number. So this is the difference between data and the information. Okay, the same thing that I explained, it's given, it's shown here. Let me just zoom it out a little bit in this picture. So this is the Middle Tennessee State University's faculty database, which has individual fields where somebody can enter the member ID, first name, middle name, last name, and all their associated results. Then if you gather all those data together, they come up like this into a resultant format of a table, which is called as a raw data. Again, that doesn't have any meaning, correct? In the C part C, we have that data information in a summary format. Let's say we want to find out all the faculty, their all their with their ranks. Let's say instructor, assistant professor, associate professor, professor, or an adjunct professor. We want to see how many of these positions of faculty, I mean all those faculties with all these associated positions are currently working in Middle Tennessee State University. This gives some sort of summary, but again, if you're going to represent it in a visualization or in a graphical format, again this is more meaningful to us. So we can say that this portion, the nine portion, which has total nine number of associate professor highlighted with blue segment, that is the that carries the highest volume in between all those persons, and the minimal number in the group is your two, which is your assistant professor. So less number of people are working as assistant professor, and more persons are working as associate professor. This is what the difference between data and the information is. Let me just minimize it. Okay. Now, next, we are going to see another term associated with database system named as metadata. So, what is metadata? Metadata is data about data. We can define it in this way: the data characteristics, which are such as the data type, such as character or numeric. You must have taken some sort of programming language, right? So there you have dealt with some numeric integer type or float type values or character type values. So these are the data type or the relationships that link all those data together. All these things collectively are called as metadata. What are these relationships? Relationships are an important component of database design, and what makes the relationship especially interesting is that they're often defined by the environment. Let's make an instance: the relationship between an employee and a job. So it likely is about to depend on the organization's definition of work environment, right? What is the relationship between employee and the job? For example, in some organizations, an employee can have multiple job assignments. correct? Okay, I think I'm correct. And while in other organizations, or even or in other divisions within the same organization, an employee can have only one job assignment. Let's say, I'll give my example what I do. Suppose say I teach you, right? I teach multiple courses. I teach database, I teach intro to programming with Python, I teach Java programming. So here I can say I have multiple job assignments to teach. And besides this, I also advise students. I also take part in the advising sessions carried out annually, or let's say each semester, per semester wise. Okay, so here I'm playing multiple job assignments. I'm doing multiple job assignments in Three Rivers. Okay, now after database, so the DBMS, database management system, is most important. This is something, this is the software tool using which you are going to write your SQL query. Like you have must have taken the Python or the Java course, right? And there you must have used for Python, let's say Anaconda or Python idle, or for Java you must have used Eclipse, right? So correct. Here in this topic, in this course for SQL programming, you are going to use some sort of software. And what are those software? Those are all the DBMS, or the database management systems. So MySQL or PostgreSQL, Microsoft Access, SQL Server, so and so on. So these are some of the examples. You can use any DBMS of your choice and just write your query. That's something that you want. And in our campus, we mostly use SQL Server. Okay. Here also in my videos also you will find the SQL Server. Okay. But if you want, you can choose any other DBMS of your choice. So these are some of the basic key concepts that you must know before starting our course. So that's all in this video.